Good morning, dear students. My name is Ferhan Mazher, and today we are studying the subject Cambridge O Levels Physics 5054. And today we are working on a theory paper. We call it paper 2, and we have selected May June 2022 2-1 paper. And this paper 2 belongs from the zone 1. This is my second video on this paper, and in this video we are going to solve the section B of this paper. And the section A of this paper I have already solved, and you can find this in the playlist of my channel. The name of the playlist is um, Zone 1, Paper 2, Section A. That's the name of that playlist. And you can find that playlist if you go into the playlist of my channel. You will find the Section A. The Section B video will be in another playlist. And the name of that playlist is Paper 2, Zone 1, Section B. So let's start this, and here we go. So this is the section B of the May-June 2022 2-1 paper. The section B, answer 2 questions from this section, answer in the spaces provided. Basically, you have to attempt, there are 3 questions. You have to attempt 2 questions, but because we are preparing for the exam, so we will attempt all the 3 questions. So figure 7.1 shows a toy helicopter. It can hover and travel through the air. Okay. So it's a helicopter. Okay, the student flies the toy helicopter on a journey, and it flies it journey from A to B to C to D at a constant height. Figure 7.2 is a scale drawing of the path of the helicopter viewed from above. Okay, so their question is, you can see from A to B, B to C, C to D. This is 10 meter, this is 35 meter, this is 40 meter. Their question is determine the total distance traveled by the toy helicopter. So the total distance will be 10 plus 35 plus 40. So I can show you my solution. So it will be 10 plus 35 plus 40, and that will be 85 meter. So it will be 85 meter. The toy helicopter makes the journey in 40 seconds. Calculate the average speed during the journey. You know, the average speed is total distance traveled divided by total time taken to complete that journey. So it will be 85 meter divided by the 40 seconds, and it will be, here you can see on screen, average speed is total distance by total time. It's 85 meter divided by 40 seconds, and that will be 2.125 meter per second. When you round it off to 2 significant figures, it will be 2.1 meter per second. Meter per second. Okay. So the next question, and both answers of these numericals are right. This is the marking scheme. Okay. So then the question, the B part, first portion, he says, state the difference between the distance and the displacement. You know, the distance is a scalar quantity, whereas the displacement is a vector quantity. Distance means the length of the path you followed, and displacement means the shorter distance between the starting point and the finish point. Okay, so distance is a scalar, while the displacement is a vector quantity. Okay, determine the scale used to construct the figure 7.2 and complete the sentence. 1 centimeter on the diagram represents on the path. Okay, so just measure how much is this length and in centimeters. And so that much centimeter means 40 meters. So 1 centimeter represents how much? That is the question. So look at here, I have done this. So that 40 centimeter length was, I measured it with the scale, and that was 8 centimeter. So 40 divided by 8, that's 5 meters. So it means that 1 centimeter on your paper basically is representing 5 meters on the path. This is how you will find. You actually measured this, and you divide 40 meter with this length in centimeters. You find 1 centimeter represents how much. Okay. Now their question is, using figure 7.2, determine the size of the displacement of the point D from the point A, show your working size of the displacement we have to find out. Okay. So what I will do, I will join the starting point with the finish point, and I will measure this length with the help of the scale. So that will be that is 9.3 centimeter. So 1 centimeter represents on the map, 1 centimeter represents 5 meter in actual. The distance, the displacement between A and D is 9.3 centimeter. So how much will be the actual length? So 1 divided by 9.3 is equal to 5 divided by x. So cross multiply. So x will be equals to 5 multiply 9.3, and that will be 46.5 meter. So the size of the displacement will be 46.5 meter. If our answer is little different from the answer given in the back of the book. So, but it's right. Okay. Now the next question they are asking us is determine the angle between the north and the direction of the displacement of the point D from the point A. So you have to measure this angle. They want you with the north, how much is this angle? Either you measure this angle or you can measure this angle. If you measure this angle, then that will be the bearing of the D from A, or you can tell this angle. So I have measured it with the help of the protector, and it is north 40° west. From north, it goes 40° towards west. And if I want to answer if I will answer in terms of bearing, it will be 360 minus 40, that will be 320° bearing. Both are the right answers, sir. Okay, the next question they are asking is state what is meant by velocity. Velocity is the rate of the change of the displacement. Rate of change of displacement is called velocity. You can see the answer. Okay, next. Another toy helicopter flies directly from point A to point D in 40 seconds. Explain why the magnitude of the velocity of this toy helicopter is smaller than the answer in the A first part. You see in the first part, both of the helicopter reached from point A to D in 40 seconds. So the time for both the helicopters is same for reaching from A to D, but the second helicopters moved from A to D directly, and the first helicopter covered 85 meter. So its distance is larger. That's why. So I said 85. Let me check. Yeah, 85 meters. So this second helicopter only covered a 46.5 meter length, and in 40 seconds, so its speed will be 1.1 meter per second. So in the second part, speed is calculated where magnitude of distance is in the same time is larger than the displacement. So that's why this velocity will be smaller. Okay. So we are going to the next part. He says when the toy helicopter hovers at D, its motor fails and it falls. It reaches terminal velocity as it falls. Explain in terms of the forces and acceleration what happens as the helicopter falls and reaches terminal velocity. You see, when the helicopter starts falling, at that moment, there is only one force acting on it, and that is its weight, and which is acting downward. So the resultant force will be in the downward direction, and it will be equals to the weight. So the acceleration produced in the helicopter in downward direction will be equals to the G value, which will be 10 meters per second. As the helicopter starts falling downward, its speed due to its acceleration will increase. When the speed of that helicopter will increase, it's falling down, its falling speed will be increasing. So as the speed will increase, the air resistance acting on the helicopter, that will increase, and the air resistance will be acting opposite to the weight. So due to the increasing air resistance, gradually the resultant force will continue decreasing. Eventually, helicopter will reach some speed when at that point, the air resistance will become equals to the weight. And when the air resistance and weight, they are equal to each other, and the resultant force will become zero. When the resultant force becomes zero, the acceleration of the falling helicopter will also become zero, and the helicopter will fall with the constant speed, and that constant speed is called terminal velocity. So it's a 5 marks question, a huge answer we have to provide. So let me show you my answer. This is my written answer. I have tried to write the answer. You can write a better answer. I will show you the marking scheme as well. When it starts falling, only its weight is acting on it. So resultant force is equals to weight and is in downward direction. Its acceleration is 10 meter per second square. As its speed increases, its falling speed increases, air resistance acting in upward direction increases. This decreases the resultant force. When speed becomes higher, air resistance becomes equal to weight. Resultant force becomes zero. Body falls with zero acceleration. This constant speed is called terminal velocity. When the acceleration becomes zero, the speed of the falling body becomes constant, and that constant speed is called terminal velocity. It's a 15 marks question. Sorry, 5 marks question. So this is question number 7, and its marking scheme is showing up on your screen. We have already checked these answers. So the C part is also showing. Okay. So you can pause the video and you can take your time, and this is how you will do this question. Okay, so we are going to the next question. The next question coming up on your screen is question number 8, and it says figure 8.1 shows a water manometer. When the water manometer is connected to a sealed container of gas and the tap is opened, the water level changes as shown in the figure 8.2. So when that container tap is opened, the level of the water in both the limbs of the manometer they change, and you can see here it is at 30, here it is at 70. So the difference between the levels is 40, which means 40 centimeter of water. So which means that the gas which is in the container, its pressure is 40 centimeter. I said centimeter cube, it's centimeter only. It's 40 centimeter of water more than the atmospheric pressure. So let's see what the question is thrown on us. So the first question coming on your screen is, he says, define pressure, and it's a 1 mark question. Pressure is the force acting on the, pressure is the force acting per unit area. Okay, so 1 mark question, simple and straightforward. Okay, then their question is, explain why the water levels are the same on both sides of the manometer in the figure 8.1. In the figure 8.1, you see both these limbs of the manometer, they are opening to the atmosphere. So both the limbs are subject to the atmospheric pressure. So that's why the level in both the limbs of the manometer and the level of the water is same. Okay, so because they both sides are subject to the atmospheric pressure, that's why the level is same. The next question they are asking is, explain why the water level change when the gas tap is opened with the manometer connected as in the figure 8.2. You see, when you open this tap, gas tap, so the gas comes here, the pressure of the gas is more than the pressure of the atmosphere. That's why the level of the mercury in both the limbs have changed, and it's showing a difference of 40 centimeter of water in both the levels, which means the gas pressure is 40 centimeter of water more than the atmospheric pressure. So my answer is pressure of the gas is larger, which is 40 centimeter of water, than the atmospheric pressure. Okay, then the question is, the water in the manometer has a density of 1000 kg per meter cube. They say the water in the manometer has a density of 1000 kg per meter cube. The atmospheric pressure is 1 expo 5 Pascal, and the gravitational field strength G is 10 meter per second square. calculate the pressure of the gas inside the sealed container, giving answer to 3 significant figures. You see the pressure of the gas is 40 centimeter more than the 40 centimeter of water more than the atmospheric pressure. So the pressure of the gas will be equal to the pressure of the 40 centimeter of water plus the pressure of the atmosphere. So the pressure of the gas is equal to the pressure of the atmosphere plus the pressure of the water column. So it's 1 expo 5 plus rho GH, and 1 expo 5 plus 1000 multiplied 10 multiplied 0.4. Here the rho means the density of the water, G means the gravitational field strength, and H means the length of the difference of the difference in the level of the water, and that is 40 centimeter. I will convert it into meters. When you convert the 40 centimeter into meters, it will be 0.4 meter. So your final reading will be 1 expo 5 plus 4 expo 3, and that will be 1.04 expo 5 Pascal. 1.04 expo 5 Pascal. I forgot to write here Pascal. That is the pressure of the gas. Okay. Okay. Then their question is, he said that give your answer in 3 significant figures. I have given the answer in 3 significant figures. Okay. Then their question is, the temperature of the gas inside the sealed container increases. Using ideas about molecules, explain why the water level change. You see, if you increase he said sealed container means that the volume of the gas cannot change. And when you raise the temperature, you see the gas molecules, they will start moving faster, and their kinetic energy will increase. And when they are moving faster, they cover the distance in less time. So their collision frequency with the walls of the container, that will increase, and they will be hitting harder with the walls of the container. I mean, they will be exerting more force when they are colliding with the walls of the container. Due to this, the pressure of the gas inside the container will increase. So when you will open the tap of the gas, because now the gas pressure will be higher, so the difference between the atmospheric pressure and the gas, that will be also larger. The gas pressure will be more than 40 centimeter, more than the atmospheric pressure. So the difference between the levels of the water in both the limbs of the manometer, that will be larger than 40 centimeter. So let me read it for you. I have written this answer. You can write a better answer than me, but I have tried to write this answer. Gas molecules start moving faster. Kinetic energy of the gas molecules increases. Collision frequency of the gas molecules with the walls of container increases. Gas molecules exert more force during collision with walls of container. Due to these reasons, pressure of gas increases. And that will cause more difference of level in both the limbs of the manometer. So that's my answer. Okay, so we are going to the next question. That this manometer is not suitable for measuring a gas pressure 2.5 expo 5 Pascal. Explain why. You see, for this gas pressure, if from here, if you subtract the atmospheric pressure, and that will be the difference of the pressure between the atmosphere and the gas pressure, and then you convert it into the level of the water, and the length of the water column, you will see the length of the water column will be very long. I have shown it here properly. The difference of the pressure, the gas pressure is 2.5 expo 5, while the atmospheric pressure is 1 expo 5. So the difference of the pressure will be 1.5 expo 5 Pascal. If you will represent this difference of the pressure in the terms of the height of the water level, water column, so I will use rho GH is equal to 1.5 expo 5. The 1000 multiplied 10 multiplied H equals to 1.5 expo 5. So H will be 15 meter. To show this difference of the pressure between the atmosphere and the gas, the level of the water required is 15 meter. Your manometer is only 1 meter. So you cannot use this manometer. Difference of level of water is 15 meter required. The manometer is only 1 meter long. So you cannot use this manometer for this large pressure of the gas. State one change to this manometer that allows it to measure a gas pressure of 2.5 expo 5 Pascal in a normal school laboratory. So you have to change the liquid which is you are using in the manometer. You can use liquid whose density is much higher than that of the water. For example, you can use mercury instead of water. Its density is much higher as compared to the density of the water. Use a liquid who has density more than that of the water. So that was question number 8. So my dear students, you can see the marking scheme of the question number 8 is showing up on your screen. You can pause the video. You can take your time with this marking scheme. So the marking scheme of the question number 8 is showing up on your screen. You can pause the video. You can take your time. Okay, so we are going to the next question. He says, table 9.1 shows details of 7 different nuclides. Okay, hydrogen 2 and hydrogen 3 are isotopes of the element hydrogen. The first question is, define the term isotope. Isotopes are the atoms who have the same proton number, but they have different nucleon number. Their mass number is different. Atoms who have the same proton number but different nucleon number. They are known as isotopes of each other. Okay, then he says the equation for the decay of the phosphorus 32, P32, as it emits a beta particle is as following. So explain whether the equation shows Q is another isotope of phosphorus. Q is not the chemical symbol for the atom. Okay, these two, they are not isotopes of each other. The reason, you see its proton number is 16, its proton number is 15. For the isotopes, the proton number is always the same. For the isotopes, the proton number is supposed to be same. Their proton number is not same. So the P and the Q, they are not isotopes of each other. P and the Q have different proton numbers, so they are not isotopes of each other. Simple. One of the sources in the table 9.1 is used in a medical procedure to detect unusual bone structures. It is injected into a patient and the radiation emitted is detected outside the body. State which source is in the figure 9.1 is most suitable for this type of medical use. You see, we are going to use that who emits such radiation which can penetrate and come out because you have injected the liquid into the body. So we have to use that material who gives such radiation which can penetrate through the bones and which can penetrate through the, through the organs and tissues and flesh. So we cannot use any radiation who is giving alpha particles because the alpha particles penetration power is very low, so we cannot use them. We can use beta or which is giving gamma. Beta has here only two places we have beta particle. Its half-life is 12 years. Here we have beta for 22 minutes, and here gamma 74 days, and here we have beta 14 days, and here we have gamma 6 hours. So it will be better if I use gamma, who has 6 hours. Technetium will be better option. It is giving out gamma rays, and its half-life is 6 hours. You see, 6 hours is a very good time. That's enough time for that liquid to reach the affected area, and the gamma rays can penetrate through the skin and the flesh and the organs, and they can come out and you can detect them from outside the body. And 6 hours is long enough time that the doctor can do all its examination. Whatever examination he's making or diagnosis he's making, he will have enough time. And the beta can also be used, but its half-life is 22 minutes. 22 minutes is not enough time for a doctor to make examine. Okay, so our thing state which source in table is most suitable. Technetium 99, I think technetium 99. And then his question is explain two reasons for your choice. Okay, so I have already discussed the reasons. Gamma rays have strong penetrating power, so can be detected from outside the body. 6 hours half-life is long enough for the radioactive liquid in the injection to reach the bones, and doctor can examine. That time is long enough, and that time is not that long enough that the patient will remain radioactive irradiated for a very long time. So you see, it's a 2 marks question. I hope you understand. Radon gas is one natural source of the background. It says radon gas is a one natural source of background radiation. Some causes of the background radiation are man-made, for example, X-rays. State one other natural source of the background radiation. The most famous natural source is the minerals in the soil, radioactive minerals in the soil, and cosmic rays. Cosmic rays. So I've written the answer. I have written cosmic rays, and you can also write. State one other man-made source of the background radiation. The man-made source of the background radiation can be many. Nuclear bombs testing, it can be a source, and leakage from a nuclear reactor, and that can be a source. And means I mean the the fuel of the radioactive material, once it's used, it is disposed, and if it's not properly disposed, it will be giving out radiation. So these are the some sources of the background radiation which are man-made. Okay, then he says, so my answer was leakage of radiation from a nuclear reactor. Okay, state one harmful effect of the background radiation. When you are exposed to the background radiation too much, it can cause skin cancer. And okay, so now the next thing is, he says one fusion reaction that occurs is shown here. This is isotope of hydrogen. This is isotope of hydrogen. They join together by the fusion, and they make the nucleus of helium. And with this, something is given out. You see its mass number is 5 on this side. The mass number here is 4. So its mass number will be 1. The proton number is 2 here. The proton number is 2. So the proton number here is 0. So this is something which has a mass number 1 and its proton number is 0. So it's definitely a neutron. Okay. The question is complete the equation to show the missing proton and nucleon numbers. Deduce the name of the particle X. We have done both the parts, discussed both the parts. So here the mass number is 5, here mass number is 4, so here the mass number will be 1. Here the proton number is 2, so here is 2, and so here will be 0. So the name of the particle will be neutron. Okay, then he says suggests where this fusion reaction takes place. The fusion reaction is taking place on the stars and in the core of the sun or on the sun. So compare the properties of the alpha particles and the beta particles in terms of their ability to penetrate through the material, ionizing effect, deflection in the magnetic field. So you see the alpha particles, then their penetrating power is very low as compared to the penetrating power of the beta particles. The alpha particles can only travel up to 5 centimeters in the air, while the beta particles can travel up to many meters in the air. The alpha particles can be stopped with the paper, but the beta particles cannot be stopped with the paper. They can be only stopped with the 5 centimeter, 5 millimeter thick aluminum foil. So that's about the penetrating power, penetrating ability, and ionizing effect. The alpha particles have higher ionizing effect as compared to the beta particles due to their larger size. And deflection in the magnetic field, both the alpha and the beta, because they have opposite charges on them, so they deflect in opposite directions in the magnetic field. So this is a 3 marks question. So let me show you my answer. You can write a better answer. I have discussed the answer. I've written also, but always write a better write a better answer. Try to write a better answer. Okay. So beta particles can penetrate more than alpha particles. Alpha particles have more ionizing effect than the beta particles in magnetic field. Alpha and beta particles deflect in opposite directions. So this was the question number, I think 9. And so the marking scheme of the question number 9 is showing up on your screen. You can pause the video. You can pause the video and you can read these marking schemes carefully. So let me bring this here. So please, you can stop this. I mean, you can pause this video and you can take your time with this. So my dear students, today, we have done May, June 2022, Physics 505421 paper. This paper 2 belongs from the Zone 1. And in this video, we have completed the section B of this paper. I have done 2 videos on this paper. This is the second video. In my first video, I have solved the section A of this paper. If you find this video interesting, useful, and you think that this can help your friends and your class fellows, your junior students, and your teachers, share the link of these videos with them. Also, share the link of this video onto your Facebook account, onto your Instagram account, and onto your Twitter accounts, because that will help me to promote my channel and I will be able to continue this work. I think it's a great blessing for me that I can, through this YouTube channel, help so many students of the Cambridge O levels around the world. It's a blessing for me. Thank you very much, everyone. Have a good day. God bless you all.